Well, hey everyone, and welcome to another episode with your girl Audrey Codner from ACG Math Tutoring. A is for algebra, C is for college algebra, and G is for geometry. So, if you guys are new to my channel, welcome on in. For those that are returning, it's always good to see you come back. So what we're going to work on today is a little splice of what we were doing towards the end of yesterday. So yesterday, I was working with, solving radical equations, and everybody was rocking with it, and everyone's doing it. And then I started to do angles of elevation and depression, and then that's when everyone started to leave. Well, let me tell you, people, there is no escaping of this stuff. Okay, so if you are trying to pass that TEAS exam, if you're trying to pass the GED, the ASVAB, the ACCUPLACER, so you can score high enough that you don't have to take basic math, you're going to need to work on some of these things, especially when we get to the SOH CAH TOA. So there's no escaping. I know going from one concept to another probably freaked you out, but guess what? You're going to have to deal with it, okay? So, we're going to do a little bit of Pythagorean Theorem, and then we're going to take our little, just small step, because I think I went a little too far, with the trig. All right, so as you guys are coming on in, go ahead and tap away. I love that there's 19 people here, and we already got over 300 taps, which is fabulous. All right, so 922 Dukes, how you doing? Janice, how are you doing? Okay, I think that's M. Pita. That's what I think it is. All right, so welcome on in. So as we all know, once I get to 1,000, that's when I start to get to teaching. So Pythagorean Theorem, I'm going to give you just a small synopsis, is you have your a squared plus b squared equals c squared. Your a and your b, those are the legs, okay? Those are your sides. Whereas the side that's directly across from the 90 degree, that is going to be your C, aka your hypotenuse. The hypotenuse is always the longest side. So if you try to do anything with right triangles, okay, this only works for right triangles. If you look directly at the side across from that 90 degree angle, that's going to be your longest side, your hypotenuse. So I'm going to say hype for short. All right. I'm doing okay. All right. So awesome, we're getting there. So now we want to basically take this step by step, and that's exactly what I do. So I'm hoping that we still have internet because it's starting to rain here in lovely Baltimore. All right, so we have our a squared plus our b squared equals our c squared. So the c squared is the c is what we're looking for. Now, the a and the b are going to be your two legs. Your two legs are interchangeable. So it doesn't matter if I make this 15 or this 15, okay? You're going to get the same answer either way. And I know because we got this so engraved in our heads that we always put the smallest number with the a. That's just what we do, all right? But no matter what, you're going to get the same answer. So now we have our 8 squared. 8 squared is not 16. Stop it. Okay, this is 8 squared. That's 8 times 8. 8 times 8 gives me 64. Okay, 15 squared. That's not 30. That's 15 times 15. That gives me my 225. And you're probably like, well, how did you get the 225 so quickly, Audrey? Well, let me show you. So what I have in my handy dandy notebook, if I look up my 15s, so we have like, if anything, we want to get those two numbers. So we got like 225. I won't have 225 in here because it only goes up to that. But in my new book, I added the perfect squares and cubes. So it's not inside this one. I almost forgot. That's how much working I've been doing. I forgot that this is not the new one. Yes. All right, so you have your 225 and then you have your 84. That gives you 289. So if I come here, I got my 289, and that's going to equal my x squared. So remember, in order for us to take away that square, we have to do the inverse. And the inverse of a square is a square root. So I know a lot of people probably saw it like right away. That gives me my 17, because 17 times 17, that gives me my 289. So my hypotenuse, the length of that, is going to be 17 centimeters. Got to make sure we add the measurements. All right, yeah. So those that put in 17 and had question marks at the end, drop the question marks. You were correct. Okay, what's the name of this book? Well, this is my Ultimate Math Notebook. This is one of many covers. Yes, there is a left-handed edition that is out and about and ready for you to purchase. Yes, I finally put the finishing touches up on that bad boy. So if you do want to get it your own, all you have to do is just go right here. Okay, go there. Take a screenshot. Ready? It's going to go away in 5, 4, 3, 2, 1. There we go. All right, so we're gonna do like all our little shameless plugs, quick and easy. All right, so let's kind of do a little advancement, shall we? Let's just take a step up. So let's see if we could fit this whole thing in, possibly. Let me tape it down before the wind takes it. All right. Okay, so we should be pretty much solid after this point. So we have a situation here, and sometimes in your exams, you are going to see diagrams. You are going to see, situations that you got to pull from your diagram. Last one. There we go. All right. So the diagram shows below a shaded parallelogram drawn inside of a rectangle. Okay. So we're going to use Pythagorean Theorem, okay, to find the hypotenuse of triangle A, which is over here, okay, and the hypotenuse of triangle B, which is over here. And we're going to take it to 1 decimal place. So you're probably saying, all right, Audrey, where am I going to start with this? Well, let me show you. Well, we know that this parallelogram is going to be inside of a rectangle. The one thing that we know about rectangles, so if you're not sure, let me come over here. So right here, rectangles. What do we know about them? Opposite angles are equal. The opposite sides are parallel. Its diagonals bisect each other. The diagonals are equal and has 2 axes of symmetry. So you can get your diagonals coming here and your diagonals coming here. And we also know it's going to give me not only the same, but it's also going to give me 90-degree angles. All right, so that's one thing that's missing. So that means this part is 90-degree angle, as well as this part is 90-degree angles. So we can pull some information. Now, which one do you think I want to tackle if I want to find the hypotenuse? Should I tackle the B or should I tackle the A, based off of the information that they're giving me? What do we think? Okay, Mom, what grades of this book in particular is for 7th through adults? Yes, good. So 9/20/22 Duke saying B, Choppers, #1 fan saying B. Okay, Tazzy saying BB. Okay, right, because take a look. We know one of the legs. We know the other leg. So it'll be easy for us to find this hypotenuse. So if we do, I'm going to raise it up to about here, we can do our a squared plus b squared equals c squared. And I know that a lot of people are like, oh, Audrey, the answer is this. I'm like, I know. But trust and believe, there are a lot of people that are taking the TEAS test, the GED, the ASVAB, the ACCUPLACER, that are just like, where did this come from? So it's easy for me to just say, let me break it on down. All right, so I'm going to say my 3 is going to represent my A. And then I'm going to say my 5 is going to represent my B. And we are looking for the C. Okay, we're looking for the hypotenuse. So 3 squared, that gives me 9. 5 squared, that gives me 25. And it's going to equal my x squared. All right. Are we good with that? It's not 6 and 10. It's going to be 9 and 25. So all we have to do is add up the 9 and 25, and we get 34. And 34 is going to be my x squared. And remember, in order for me to get rid of the square, I have to do its inverse, which is a square root. Because the square and the square roots, they're inverses of each other. So they're basically going to cancel each other out. And then I can bring down my x. I can bring down my equals. And now I have the square root of 34. So you're probably saying, 34. Like, can we do that? Like, can we actually do that? Well, let's take a look. So if we come over to 34, so the only factors of 34 is 1 and 34 and 2 and 17. So we're not getting a perfect prime combination. Not just because there's no reds in here, well, that is, but there isn't a perfect prime combination. If I just break down the square root of 2 and the square root of 17, I'm not going to get a whole number out of that. I'm just going to have my answer with 2 radicals. So that doesn't make any sense. All right? But they would love for us to find that hypotenuse and put it in 1 decimal place. All right, no problem. So they're assuming, and I'm going to tell you on those GEDs, ASVAB, ACCUPLACER, they're going to keep the answer as the square root of 34. Okay, because remember, you can't use a calculator to figure it out. So they're not, trust me, they're not going to. But if I do the square root of 34, let me see if I can get my angle without too much of a glare. Okay, I got 5.8. Zoom for you. There you go. I have 5.830951895. Sounds like a phone number. No, I'm not going to call it. So if anything, if we could round that to 1 decimal place, what would my answer be? Yes, point. Okay, why couldn't you do, because the square root of 2 is prime and the square root of 17 is also prime. So I can't get anything out of it. I'm just going to have 2 radicals in my answer. And trust me, math people, we don't like to have too much junk. We like to keep it nice and clean. All right. Yes, 5.8, Liv, good. 5.8, hi, Michael. Okay, don't round it to the whole number, guys. Keep it as 1 decimal place. 1 decimal place, okay? Yeah, so 5.8, good. Okay, not a whole number, 1 decimal place. There we go, Molly. There we are, 5.8, good. So since we are rounding, let me unzoom a bit. Oops. So since we're rounding, this is not going to be an equal sign. If it's rounding, we're going to use a wave. That means approximately. Okay, so we have our 5.8. And the reason why I'm saying approximately is because we round it. Okay, we had all those other lovely digits right after the 8. All right, so we're using the approximation sign. All right, but if I wanted to, am I going to get the same thing for A? Will I get the same exact thing for A? Okay, no, that's okay. Yes. Yes, A and B, right. Good. So saying no, saying yes. Okay, Pog saying yes. Okay, so think about those philosophies. Watching clouds, saying yes. All right, awesome. Thank you for the gift, appreciate it. How you got that without the calculator? No, I can't. You want me to tell you the truth? No, I can't. Because without the calculator, I'm keeping it as the square root of 34. I'm not going to lie to you. All right. All right, surely. So, here's my thing. Remember what I said about a rectangle. Okay? Let's show it up again. Okay? This is what we know about rectangles. Opposite angles are equal. Okay? So, if this is 90 degrees, that means that's 90 degrees. All right, opposite sides are parallel. All right, so this side is going to be parallel to that side. This side is going to be parallel to this side. Okay, got that. Then we're talking about the diagonals and has two axes of symmetry. But if we zoom in to the picture, it's also giving you additional. Notice these tick marks. That's one tick mark. That's one tick mark. That's two tick marks. That's two tick marks. The tick marks are symbolizing congruency. That means the length of this side is equal to the length over here. And the length of this side is equal to the length over here. So if we go back, and let me unzoom a lot. Okay, if we go back, if we're saying that the length of this is 5 centimeters, that means the length of this side is also 5 centimeters. They're saying this piece is 3 centimeters, whereas this piece is 3 centimeters. So if this is roughly 5.8, that means this is roughly 5.8. All right, so yes, whatever we get for the hypotenuse for B is going to be the same for the hypotenuse of A. Okay, nice. All right. Okay, keep on moving, keep on tapping. I love it. Over 400 people in here. Let's go. We should be easily at 12,000 right now. All right, let's see what's going on in the chat. Okay, I wish my math in college was like this. I miss it. Nice to refresh. Awesome, good. Let the numbers go on for infinite, but you can't fit all of it inside. Enjoyable knowledge. There we go. Ooh, I don't know what happened there. Kind of got frozen for a second. All right, cool. Okay. All right. So, throwing a couple of word problems. Okay, they always use some things like this. Always, always, always. All right, so go ahead. Let's hit with a mad tap while I'll set everything up over here. For some reason, well, I don't know why I'm saying for some reason, because my electricity might go out, even though the storm just passed. But, you know, sometimes the Wi-Fi just wants to do its own thing. Okay, all we need is less than 2K left. Let's go, let's go, let's tap. We got this. Do not be stingy with your chat, love. All right, well, hello, Layla. That's all right. Or Lay. So you're going to go to geometry for your sophomore year? All right, welcome in. So usually this is a place where I like to kind of help people get over that math phobia. Okay, we try to take on whatever concept. For me, I try to take on concepts that I'm getting from a lot of my tutoring clients. And 1 second. Almost had a danger here. Okay. And my client was really struggling with Pythagorean Theorem. And I have clients from like 7th grade all the way up to adults. And a lot of people are trying to get help with their college algebra because their final exams are either Wednesday or Thursday of this week. So things have just been getting a little busy, and whatever I notice people are having problems with, I'm just right away just coming on here and breaking stuff down. All right. So yeah, so you're more than welcome. Everyone's more than welcome to come here. This is like judgment free. We're taking it step by step. You know, sometimes we do geometry, sometimes we do heavy with the algebra, especially with the graphing. So it basically fluctuates. So enjoy. All right, so we have a trapezium. So a lot of us, we know it as a trapezoid, okay? So we want to use Pythagorean Theorem basically to find the value of k, and we want to put it in 1 decimal place. So you can see right away, we have like different things that's going on here. So instead of looking at it as a whole, let's do a little bit of alteration. It's almost like, you know, let's get a little filler, see what we can do, you know. Not too much reconstruction, but just a little bit. So I'm thinking about, let's kind of break this up into 2 shapes, right? So instead of one big trapezoid, okay, you have your base 1 and you have your base 2, let's break it up into a rectangle and a triangle. So the reason why I'm saying a rectangle is, 1, we got these 90-degree angles. All right, we're kind of doing like an assumption that base 1 is not equivalent to base 2, but it could be. All right, so we don't know if it's a square or a rectangle, but since I'm seeing 90-degree angles, that means there's a 90-degree angle there, and there's going to be a 90-degree angle down here. But if we're saying that's going to be my perpendicular bisector, if I may say, okay, that means this is going to be a 90-degree angle. So now, instead of looking at the whole entire thing, we're just going to look at part of it. As soon as I can find my papers, what is going on? Here we go. So I'm going to cover up kind of like this side, but I need one more bit of information. What do you think I need? Let me see what we got there. All right, Y's Tycoon is saying 20 there. Okay. You think we're going to use cosine or tan. Okay. Triangles equal parts to 22 there. Okay. All right. You were right there. Surveying triangles? Not really. Okay. Grid lines. Yeah, the base of the triangle. Okay, we're going to try to solve for k, but we need something. We kind of need to know what this is right here, but they're giving us something. Now that I created this height right here, I know I can use something in order to break it down. We don't even have to get to the trig functions, guys. Not even yet. Okay? We could do the 30 minus k. The 20. Thank you. Make it easy for yourselves, people. Everybody's already doing dissertations, splitting atoms, all kinds of stuff. Use what you got to get what you want, people. Right here, they're giving us 20 centimeters on this side. Guess what? If that's 20 centimeters, that means this right here, this is also 20 centimeters. Okay, the length of this side, right? So now we can definitely cover this bad boy up and focus on the triangle. Okay, so we got our a squared plus b squared equals c squared. All right? They gave us one of our legs. If you want to say, all right, I'm finding my unknown. And then the other one's going to be 20 squared. And it's going to equal my hypotenuse. How do I know it's my hypotenuse? Because if I go directly across from that 90-degree angle, that's always going to be my longest side. All right? So this is my 22 squared. All right? So if we think about it, we really want to subtract 20 squared on both sides. Now, please don't tell me, oh, the answer is 2 squared. No, don't make me fight you. Okay? Do not make me fight you. All right? So we have our x squared. Now, our 22 squared. Was it 484? So we got our 484 minus my 400, because 20 squared is 20 times 20. That's 400, okay? So now, 484 minus 400, we have our x squared is equal to 84. Like we've been saying, if you want to get rid of the square, we have to take the square root. Squares and square roots are inverses of each other, so they cancel each other out. So now we have our x equals. Now, square root of 84. Okay, it's even. We might have a chance. So if I go here to 84, okay, so if I go to my 84, let me back up just a hair. All right, so we have 1 and 84, 2 and 42, 3 and 28, 4 and 21, 6 and 14, 7 and 12. Which will be a perfect prime combination? It's going to be the 4 and 21. And you're probably saying, well, Audrey, you can break down 21 with 7 and 3. Exactly. 7, prime number. 3, prime number. 4, perfect. Okay? Square root of 4 will give me 2. We don't want to have 2 radicals in our answer. That's gross. Okay? You have those special radicals that you won't be able to break down, but it'll be tempting to think that you can. Like, say, the square root of 6, okay? The square root of 15, the square root of 21. You can break them down, but you're only going to break them down into 2 separate radicals. You're not going to get a perfect out of it. All right? So, if I break down, we got the square root of 4 and the square root of 21. Square root of 4, that gives me 2. And then we have our x equals, and we bring down the square root of 21. I know my lovely geniuses are going to say, plus minus, Audrey. What happened to the plus minus? Can we have a negative, can we have a negative distance? No. You can go in the negative direction, but you can't have, oh, that's how much negative 5 centimeters is. Like, no. Okay? So that's why we focus on the positive. Now, if we're finding our solutions and we're not putting into a real world situation, yes, you need to show your 2 answers. Okay? All right? So I would leave it like this if it was, GED, ASVAB. I always solve and I start checking my answers. So, but if they want us to round, remember they said earlier, they want us to round to 1 decimal place. So that's when, I guess it's one of those situations, if you want to do the handy dandy calculator. So we know it's going to be 9 something. Here we go. And zoom. All right. So we have 9.165. What is it as a decimal? Yeah, I know. That's how life is. Every time you think you're done, you're not. Okay. All right. Yes, 9.2. Good, Janice, Chopper, good. All right, 9.2. That's the thing. You're like, oh, I see 9.1. Yes, but the next digit is a 6. All right, so here's the thing. If it's 5 and above, we give it a shove. That means we will add 1 to that. If it was a 4 and below, we leave it alone. Right at that 4, we drop everything and just leave it as is. But since 6 is larger than 5, we're going to add 1 to that 1. So that's how you get your 9.2. And we're going to use x approximately 9.2 centimeters. Okay? If you want the exact, oh, thank you. Who is this? Hi. Hey, Marky. My goodness, a galaxy? Good girl. So if anything, if they say they want the exact, you're going to keep it as 2 square root of 21. If they want the approximate, that's when you're giving the decimal rounded. Okay, that's the key. So you always got to check your instructions. Okay, check your instructions to make sure, are you giving the exact or are you giving the approximate? If they say the exact, and let's say you're working with circles, that means you don't have to break down pi. You can just put the symbol of pi in your answer. If they said they want the approximate, that means you're going to have to do some rounding with pi and then do your multiplication. Okay, so those are the key words because that will save you so much time. If they say they want the exact, boom, done, click, chosen, move on. Okay, but if you have to do a little bit more, you have to do a little bit more. All right. All right, so that takes care of this bottom portion. Okay, we're not done. So this takes care of 9.2 centimeters right here. But we're looking for K. Let me unzoom a lot. Okay, we're looking for K. So what can we do to find K? K centimeters. What can we do? What can we do? Okay, period since 30 minus 9.2. Fishing pill, how are you? You're saying 20.8. Then we have, oh wait, hold on. Things are starting to get a little fast over here. Okay, Michael's saying 30 minus 9.2. Chopper and 30 minus 9.2. Samuel, how are you? 30 minus 9.2. JT, 96720 saying 30 minus 9.2. Robert, how are you? 30 minus 9.2. Mr. Oh, I haven't seen this last name in a minute. How are you? Okay, it's like 30 minus 9.2. Jess, 30 minus 9.2. Pog, 30 minus 9.2. Gabe, 30 minus 9.2. Awesome. And 30 minus 9.2 for everybody that wants to know, it is 20.8. Yep. You take what they give you. As I like to say, use what you got to get what you want. All right? So we used... All right, my internet just went out. I think you guys are still here. You guys still here? That was weird. Okay, you guys still here? All right, good. Yeah, all of a sudden there was just like, no! And then it just came right back on. All right. Yeah, we just had a storm, so yeah, anything's possible. Everything's possible. All right, so we had to figure out what this side is, knowing that the whole length here was 30. All we had to do is subtract 30 minus 9.2, and we can get what was left over. All right. Right? It's all kinds of fun. But Sometimes it just gives me a reminder. Did I pay the bill? So I am not even going to sit here and lie, because Xfinity, they will cut your stuff off in a heartbeat. They ain't playing. So that was my summer. How was yours? Oh, man. All right, let me give another situation, and then we're going to go into... Then we go into the SOH CAH TOA just a little bit more. I know a lot of you guys were like, nope, not doing that yesterday. Well, guess what? I'm bringing it back like hot pants. That's what we're going to be doing. Culottes. I was like, I know someone was like, ooh, girl, did she just say culottes? I'm like, yep, I did. I mean, I'm not 50, but, you know, I'm up there. Ooh, that'd be fun. A Greek page? Oppa! Oppa, Mark! Oppa! Yeah, you did find a Greek page. All right. Hope it isn't bad. Oh, it's terrible. All right, so let's take a look. All right, so the following triangle is not a right-angled triangle, and so you cannot do the Pythagorean Theorem directly. Notice the word, directly. Find the length of x, and I love how she shortens it, to 2 decimal places, okay? So they're giving us a little bit of information. So they're telling us that these 2 sides are exactly the same length. They're saying the length of this triangle, the base of it, is 100 centimeters. And they're telling me that its height is 35 centimeters. Let's do some manipulating. Okay, let's do some manipulating. Okay, make a height. Why is it when I'm busy, everybody and their grandmama want to talk to me, but when I ain't doing nothing, nobody wants anything? So anyway, going back to us, because I swear, it's so crazy. Oh, it's Sunday. Audrey must be bored to tears. No, she's not at all. Good. No, that one was a phone call that time. Right? That's how it is. That's what I'm saying. Yes, MD, you're in my brain. How's it feel? Squishy? Yeah, I figured so. Because this is a big hot mess. All right, so once we split this, then we got our height of 35 centimeters. Right here, right smack right here. Okay? So we created, I'll say, a perpendicular bisector, creating that 90-degree angle right there. Wow. Okay? So now we can focus. But what would be the length of my base? Okay? What would be the length of my base? Because it's definitely not going to be 100. What would be the length of the base now? Okay, Tramp saying 50, Pod saying 50, Jennifer 50, MA, half the base times the height. Okay? But we're looking for the side lengths. So yes, it's going to be 50 centimeters. Yes, Duke saying 50 centimeters. 808 saying 50 centimeters. It'll be half the current length. Current base. Got you. 50, yes, 50 centimeters. 50, Jess, love it. Now, if you're a visual person, almost like myself, and you just want to sketch, here's your this, here's your that, here's your that, and that's what we got. So this is what we're looking for. We know that this is going to be 35. We know that this is going to be 50. and we are looking for the x, okay? So whatever we get over here is going to be exactly the same that we get over here. So Pythagorean Theorem. Whoopa. So we have our 35 squared plus my 50 squared is going to equal my x squared. All right. So, handy dandy calculator. 35 squared. That, I'm going to be truthful, do not have that in my brain. I'm not even going to sit here and trip. Okay. 1,225. Okay. With the 50 squared, we know that that's going to be 2,500. So now, let's get that 2,500 plus that 1,2025. Then we have our, whoops, got a little crazy there. Then we have our 3,725. Got that part. Oops, almost forgot about the 7. Going too fast. All right, so that'll give me my x squared. But then we have to take the square root of both sides. Now this is not going to be pretty because I know this is definitely not a perfect. But if they want us to do it at 2 decimal places, give what the people want, okay? So we have KP is saying 61. Give me 2 decimal places. What was after that? Oh. So are we at that day, Duke? Because I know the people that I had today, they were cursing his name. And I was cursing at the fact that they were cursing his name. But we shall say his name sweetly. Yeah, so we got our 61 and 300ths. Yes. So we have our 61.03, and this is centimeters. That is going to be my unknown side. Okay, that was my unknown side. Okay. All right, bud, what we got? How do you know that bottom is exactly 50 if it's not a right? But we created a right angle. So if you remember anything about perpendicular bisectors, when you're bisecting this angle, okay, so you're making a perpendicular bisector. So perpendicular bisectors always create 90-degree angles. So we, based on that philosophy, made a right triangle. Okay, we created a right triangle. Yes. And let me take a quick look now that my computer is officially back on. So, because I'm on my phone doing the live. I am not fancy yet. Yet is the operative word. Okay. Okay. You're so scared of 7th grade. No, don't be scared of 7th grade. Take it on like a champ. Let's go. There's no time for fear. Fear? Okay. I think we're all good. Okay. All caught up with all that. All right. All right. Soon I will be. Whew. Be a dangerous time. Dangerous time. Okay, how did I get the 61? Handy dandy calculator, darling. Let me see if I can get it. Okay, so we took our 1225, which was the 35 squared, and then we took our 50 squared, which is our 2500. Add those two together, and we get our 3725. But then if we take the square root of it, you're going to get your 61.03. 77808. Okay. Do you divide, subtract, or add? Neither. Okay. All right, you see. Not a problem. Not a problem. Okay. Yeah, so we always take the square root when we're dealing with squares. All right. So That was Pythagorean Theorem. And that's what we do. I mean, that's what we gotta do. So that was Pythagorean Theorem. I know a lot of you are enjoying it. You're like, yay, this is awesome. I love it. I'm gonna go and do fun stuff now. No, you're still sitting here. Because now we're gonna kind of go back. Not too far back in time. Just a spell. Just a little spell. With the whole thing called SOH CAH TOA. Okay? And you're like, what? Just listen. All right, go ahead and keep tapping on up. Let's do a little mad tap. Let's see if we can get to like 30. I'm not asking for too much. Okay? I'm not asking for too much. Just a little mad tap here. So, we're going to do a little intro to Trig. I love how one person's like, you actually call this fun? I mean, it's entertaining. You know, how some of the things are created. And especially like, why do we create certain shapes for our cartridges, and why do we have like pizzas in square boxes and not round boxes? And you know, why is there always so much air in the chip bag? And you're like, what's up with that? So, believe it or not, a lot of that is math. So it's always something kind of nice to just take a look at. And then if you really seriously can't stay, I'm not forcing you. I'm not going to like find your address, hunt you down or anything like that. That would just be mean. But just for you to kind of have an understanding. Yeah, that was too easy. All right, well, do what you got to do. All right. I know, right? Period. That's what I'm telling you. But I understand the reason why you want to make sure that the chips are going to be secured and good with shipping and keep it nice and fresh and blah, blah, blah. But seriously, yo, fill up the bag. Because if Trader Joe's can sell their chips and almost fill up the bag, and it costs a heck of a lot cheaper than most of the chips you get in supermarkets, come on. Come on. Fill up the bag. All right, so we are working with, again, a little bit of right triangles, but this time we're kind of involving this angle. This angle is called theta. See, it's all Greek tonight. Whoopa. So theta is representing my angle until I actually have an angle measure. Now, the way that you basically address, there is 3, but altogether there's 6. But there's 3 that we're going to focus on tonight. That's it, okay? The first one is called the sine function. Okay? Now, sine is usually represented by SIN. So if you ever look on your calculator, be it this calculator, be it your Apple calculator, and you always see like these 3 letters right here, these 3 buttons, this is what we're talking about, okay? Sine, cosine, tangent. So we're going to actually be playing around with those things. Now, the sine of theta, because it's all based off of the angle, the sine of theta goes by the ratio of your opposite, based off the angle, over your hypotenuse. Hence why we say so, because it's your opposite over hypotenuse. SOH, sine, opposite hypotenuse, over hypotenuse. The next one is called your cosine. And that's short for cos. I know a lot of you guys always say cos, but it's just cosine. Okay, dealing again with your theta. So cosine deals with your adjacent. Adjacent means next to, over your hypotenuse. Okay, CAH, CAH, cosine adjacent over hypotenuse. Now, last but not least is going to be your tangent. And tangent is short with tan. And tangent is the only one that has nothing to do with the hypotenuse. It basically takes the numerators of sine and cosine and make its own fraction. So it's always the opposite over adjacent. So if you ever get a word problem and you notice the side that you're trying to find is your hypotenuse, that means you're going for tangent. You're using tangent to solve it. All right? So we're going to focus on these three for today. Okay? Nothing too crazy. All right? Well, hello. Sorry, my computer just keeps shutting off. I don't know what's going on. It does nothing. I go nowhere. So that's the only thing. But the way that you can tell which is opposite, which is adjacent, well, the hypotenuse, as I keep saying, it's always the side that's directly across from your 90-degree angle. Okay? So this is always going to be your hypotenuse. So we got that down. But how you can tell if something is opposite or adjacent, it's based off of the angles that you're using. So here we have the angle of theta. So I'm using this angle. So if I want to see opposite, that means the side that is directly across from that theta will be labeled just for that triangle, right? Just for that angle. That's going to be labeled opposite. So this is always going to fluctuate. The only one that doesn't fluctuate is your hypotenuse. That's always going to be right across from your 90-degree angle. Now, based off of theta, if this is opposite, that means this right over here, that's going to be your adjacent side, because it's next to your angle of theta. Okay, it's right next to that. All right. So when we take a look at all of this, just based off of this triangle, my opposite is over here, my adjacent is over here, but my hypotenuse is over here. Okay. So when they're trying to give us, or they want us to figure out what the ratios are, okay, in order to figure out the ratios, you have to figure out which angle is going to be your theta. That's what's most important, okay? You can't just say, oh, okay, I'm using this angle because I felt like it, but they're indicating this angle. You'll get an answer, but it'll be wrong, okay? So we don't want to have wrong answers as best as we can. All right, so let's take a gander. Let's look at a couple of examples. Wrong color. And let's go to here to here. All right, so this will be my 90-degree angle here. Let's say that This is going to be 12. This will be 35. And this will be 37. And we're using, let's see if I'm going to label. This will be angle X, this will be angle Y, this will be angle Z. So let's say I want to know the tangent of angle Z. Okay, the tangent of angle Z. So you should be giving me a ratio, a fraction. So if I'm saying the tangent of angle Z, I'm looking at angle Z. So angle Z is going to be my theta. So tangent, if we recall, that's opposite over adjacent. So the side that's opposite Z is going to be, good Ashley, is going to be 12, because that's opposite angle Z. And my adjacent is not going to be 37, because 37 is directly across from my 90-degree angle. So I can always mark this my hypotenuse regardless of what angle I'm using. But we want the adjacent. So the adjacent is going to be the other leg, which is 35. Okay. All right. Nice. Okay. Hey, JB. Thanks for the stuff. Appreciate it. All right. So now, let's say that I want to know the sine using the same one. I want to know the sine of X, of angle X. What would that ratio be? Okay, see where angle X is. Let's see where sine is. Okay, Robert's saying 35, 37. Jan is saying 35, 37. Okay, so Jess saying 35, 37. Aon saying 35, 37. JB 35, 37. Bedsore saying 12, 37. Alexander saying 12, 37. Okay, not sure. Thank you for your honesty. Okay. So remember, we're looking at the sine of X. Okay, we're looking at the sine or X. Okay, so we're looking at angle X. This is going to be my theta. So opposite angle X, there we go, saying 35, but my hypotenuse, remember, sine is opposite over hypotenuse. So your opposite is the 35. There you go. And then your hypotenuse is the 37. Good. So we have our 35 over 37. All right. Yep, because sometimes we'll switch it around. All right, so sometimes it switches around. Okay, so what happens if I said the cosine, and then I'll switch to another one. What happens if I say the cosine of Z? What would be the cosine of Z? Aw, thank you. Reached my goal. Forgot it was the same goal stuff. Okay. So make sure you're looking at cosine of angle Z. Angle Z, not X, Z. Look at you guys, just gifting away. Thank you. Suppose I had another. Got faith. Okay. Now it's just losing its mind. I have no idea what's going on. Thank you, Michael. All these gifts. There we go. There we go. So, Aya, careful. All right. So, if I'm looking at angle Z, that's this one up here. Cosine is the adjacent over hypotenuse. Okay, so if I'm using angle Z, I'm going to mark this up one. So if I'm looking at angle Z, my adjacent is not going to be 12. The 12 is my opposite. That's sine. So we're looking at cosine. The adjacent is the side that's next to. And you're probably saying, well, this side's next to too. But this is my hypotenuse. Okay? We're looking at what's happening to the legs here. So since we have our adjacent, that gives me 35 over my hypotenuse, which is 37. Okay, do we see it now? So if I said the sine of angle Z, that will be 12 over 37. But I wanted the cosine of Z, which will be my 35 over 37. And yes, if I do the cosine of one angle and the sine of the other, you should get the same answer. Okay. Fabulous. Thank you for the follows, guys. Let's keep this going. All right, couple more. And then we're going to talk a little bit about the missing ones. All right, so this time I'm going to use my initials. Yep, my initials are ABC. Crazy, I know. After class, Dr. Skinny, Algebra tutor for my daughter. Definitely, go ahead and message me, Dr. Skinny. Yeah, I'll be able to, like, rather quickly, because I do have someone at 7, so I can do that. All right, so let's say I want you to find the sine of angle A. What will be my ratio? Oops. Let's see if I can raise that up. So the sine of angle A, what will be my ratio? Okay, Pog saying 3645. Viewed Up says 3645. Mona saying 3635. JB 3645. A 3645. I think we're getting it now. Okay, saying 4/5. Okay, Robert. So 3635. Are you over here reducing things? Reducing it by 9. I know. All right, so with that angle, you have your 36 and your 45. Okay, so if I said the tangent of B, what would be my ratio for the tangent of B? I know. What would be my tangent of B? Okay. So you got your 2736. Brooks, your 2736. 2736. Rockwell, 2736. Yes. Nice. So it's your opposite. And over your adjacent. Very nicely done. See? This wasn't so painful. Everyone just upped and jumped ship like there was no tomorrow. Like there was a fart in the room. And there was like, nope, I don't want to smell it. And then just like, nope, we're doing something new. Don't like it. Go somewhere else. I don't know why I'm saying it like that, but here we are. All right. So that's what it basically comes down to. So when you see those problems, and let me refer to the ones I was talking about. So when it comes to those problems that deal with ladders, okay, there's always a ladder problem, or someone's on a cliff, or what's the other one? Like there's an observation tower, or there's a flagpole, or a tree. Okay, so those are the type of problems, like when they're talking about angles of elevation and depression. We're talking and we're bringing in that component of trig, but we're also bringing in a little Pythagorean theorem just in case we have to find the side in order to figure out what we need to get. Okay, so this is what everyone was kind of like freaking out about. So if we say we're looking for a side, okay, let me put it over here. Let's say we're like looking for a side. I have this lovely triangle. Let's say I'm going to stick it right here. So I'm going to go from here to here. Then we're coming here. And we got something like here. Oops. Okay, so this will be my 90-degree angle right there. So let's say that this is 52 degrees. This is our missing side that we need to find. And this will be 16. Okay, let me zoom that in. All right. So if we want to find a side, yes, there is something called the law of sines, the law of cosines, but here's the fun part. You're not going to see that on GED, ASVAB, ACCUPLACER, okay? I know, we want to have fun with it, but right here and now, I know a lot of you guys are either getting yourself ready for a final, and I want you to do well in that final, okay? So I need for you to take a breath. So by the information that we know, we can use the trig, the sine, the cosine, the tangent, to help us find that missing side. So if I take a look, 1, they're not giving me any value for the hypotenuse. So right away, I should be thinking, hey, there's no hypotenuse, but they have a side here and a side here, and both of them are my legs. So that means I should really be thinking about tangent. Okay? So that 52 degrees, that's my theta. That's my angle measure that we're going to use to find out which side is going to be opposite and which side is going to be adjacent. So we have the tangent of 52 degrees. My opposite of this theta is going to be 16. So that means my adjacent is going to be x. All right, awesome, good. Okay, so now we have an x in the denominator, right? So I know I want to solve for x. And I'm going to tell you two ways. One way, which is the long way, I can multiply both sides by x, but then I really want to isolate my x, and then I can divide both sides by the tangent of 52 degrees. Or, welcome to Audrey being lazy, or maybe I should say, working smarter, not harder. If my x is in the denominator, just switch it. Because that's what's going to happen. Your x is going to be over here. You're going to have your equals 16. And it is going to end up dividing the tangent of 52. If your teacher wants to see the work, do it. I don't want you to lose points. But if you're taking a test, switch it. Okay? If your unknown's in the denominator, just switch it. All right? So now, this is going to be something that either you can leave it like this, especially if it's one of those, the advanced part of the ASVAB and the ACCUPLACER. If they're not going to give you a calculator, obviously, they're going to leave it like this. But if it's the SAT, the ACT, you see how versatile just learning all this stuff, okay? They're going to say, all right, calculate it. And the way you can calculate it is all you got to do is take your 16 and then divide by the tan of 52. Now, here's the thing. When you're in your mode, not in your mood, but in your mode, make sure it's in degree mode. Okay, you got to make sure it's in degree. Because if you put it in radians, you're going to get an answer, but it's going to be wrong. All right? And you don't have to close the parenthesis. If you feel like it, have fun, enjoy. But let's take away from that step. So if I want to round this to, let's say, the 10th, what would my answer be? If you guys can see it. Okay, what would my answer be? Matt saying 12.5. Michael saying 12.5. Period, 12.5. Awesome. Okay, you see how I'm taking geometry, putting it into algebra, then going into pre-algebra or basic math. Okay? So it's not like, oh, this is stuff I'll never face. No, you will. You will face this. Okay? So since we are rounding, I'm going to put my waves for the approximation of 12.5. Okay, 12.5 units since I don't have anything. Okay, good, JB. Okay, don't have to round it. If it's to the 10th, Jacob, if it was to the whole number, yes, that would be awesome, 13. But if they want it to the 10th, majority of the time they either want it to the 10th or the 100th position. Okay. All right. Yes. Yep. But you're still going to get the same answers. Like right now, I don't have a TI 30. I don't. Okay. But you will get, sometimes that gives you more answers than the TI 83s. So, okay. Because I remember a couple years ago, if it was like something that they had online, like you can't bring your own calculator. They will have you lock all your stuff up. So, all right. Yes. So we got all our fan clubs. Yay. All right. They let you bring yours in? Girl, you better hush it up. For the value, well, yeah, but it's Baltimore. So where'd you go? CCBC? Not CCBC. BCCC? Okay, only the second part of the test. No? Where'd you go? Did you go all the way in the county? Oh, we're trying to make it relaxed. Sad? In Towson? Oh. I didn't know they do it anymore. Huh. Okay. Yeah, because Towson usually don't do GED. That's fun. Maybe that's why. They probably didn't know. They're like, oh, yeah, just calculate right there. Did on a sneak tip. That's cool. Yeah, off of Taylor Avenue. Yeah, because I know they do praxis, but for years they didn't do GED. Interesting. Fun facts. Love it. All right, let me get one more in before I have to go and get myself ready for a client. And then while you're here, while I'm setting this up, if you ever want to see like a replay of the shenanigans that went on today, you can. All you have to do is just go here, all right, and just type in, whoop, there you go. So all you have to do is just type in either this one or my name, okay? And then I would love for you to do this, definitely do this, and this, so you'll get the latest. I just put last night's up. It took forever to upload. But last night's is up there now. So, and God knows when this one will be up there. It might be tomorrow morning. All right. But if that's what you want to do, you can go there. Also, if you want any of my services, I do private and small group tutoring. Okay, I do. And I'll tell you right here now, I normally charge $87 an hour. I know, and I'm worth every penny. But for my TikTok family, which will be my subscribers, if you want to subscribe to my free subscription, I'm not bougie yet, people. Take advantage now. I don't know what's going to happen next month, but I know things are going to start kicking off. As when I say next month, I mean next week, because a lot of my Alaska kids are coming back. If not Alaska, there's some other people are coming back early too. So yeah. And before I know, Florida will be here. And then before I know, Texas will be here. Then both my Carolina kids will be back. And Maryland's always the last. And I always get bombarded, usually in October, with my Maryland kids. So take advantage now. So definitely have like a small discount for my TikTok people, especially for you guys showing me so much love. And also there were some people that wanted to sponsor a student with tutoring. So, hey, take advantage. If you want to do any of my courses, I'm working on a workbook as we speak. Because sometimes everyone's schedule is all over the place, and I think it'll just be best just to wrap everything up and put it into a workbook for you. But if you are interested into my books as well, so that's my notebooks, my left-handed series. I don't have to say soon to be. It's already up, ready to go. Just go here if you're interested in purchasing notebooks to get yourself ready for the new school year. Okay, that comes with your factor sheets. That comes with all of these lovely pages. Okay, you got your factor sheet, you got your reminders, you got the words and phrases, all of these references in the back. And the newer books, the second edition, have more reference stuff in there. Okay, I have the arithmetic and the geometric sequence. I have the system of equations, breaking down inequalities. What else is in there? The list of roots and cube roots, because you guys are using square roots and cube roots more often. So all of those are into these books. All right. How to get it? All you have to do is just go to my private bookshelf or bookstore, because I have my own books by Audrey Codner. That's where you go. You will have to turn students away. Michael, here's the thing. I will never turn a student away. I will make room. If that's just my crazy psyche. Because I know I'll have like student athletes, and most of them don't come home until like 9-10 o'clock. I have some student athletes that play on travel teams, And sometimes it's me and them at 11, sometimes 12 o'clock, because they just came from a weekend of AAU travel. So I've done it. So I don't think I would ever turn the student away unless that student is just like way too young. That's the only reason why I would. Okay. I try. All right. So, oh, you're in Maryland too? Awesome. Needs a hey, Lori, reach out. Definitely reach out. And then if anything, in the meantime, if you guys want to watch the videos, you can come here. Just definitely fill out your contact form if you want to that. And then if you want in the meantime, watch a couple of the replays. You know, that's the reason why I put it on here, for you guys to use it and to take advantage of my wares. Just taking advantage. No, I'm just kidding. Let's see. Let's call this 24 degrees. Let's call this 14. And let's call this our unknown. All right. Tell me what my unknown is. Tell me what you want. Tell me what you need. Everyone loves Drew Hill. I wonder how many people was like moving. Okay. So you're saying, Cinder is saying we got opposite. Period is saying 14 times cosine 24. All right, so I got opposite and I got cosine. Are we on track? Which ones are we doing? Trig beloved. Hello, Liz. Yes. Joke. Pog is saying 14 sine 24. It's the battle of the sine and cosines. Let the body hit the floor. Let the body hit the floor. So you got a negative, but I realized my calculator was in radian mode. Yes, Robert. Flip it! Guys, so sine of 24. There we go. All right. There we go, period. All right. So period has came over to the sine. Came to the sine side. I know, every time I hear the word period, I just think of that girl. Period. Period. Ugh. God, it makes me so annoying. Sorry. I hope it's not you. But every time I hear period, that's what I think of. All right. So here is my theta, which is that 24 degrees. They are giving us the side that is opposite. Boom, opposite. Then they're also giving us a side that's directly across from that 90-degree angle. So they're giving us the hypotenuse. Bum, bum, bum. All right, so that means we have the sine. I saw the sine. It opened up my eyes. I saw the sine. Now we have our x over 14. Now, this is going to be different from what we did earlier. The one thing that's different is our x is not in the denominator. Okay, so right now our x is in, well, our number is in the denominator. So that means we're going to multiply both sides by that denominator. Notice I'm not using an x. Stop it. When are we going to stop using x for multiplication? Just stop. Because it screws everyone up once they get into middle school. It gets crazy. Just let it go. Let it go. All right. So that means you're going to have your 14 times the sine of 24. And that equals your x. So then you go to your handy dandy calculator. Then you type in your 14. Boom. Then you put in your sine. Da-na-na-na-na. Then you're 24. And then you hit your enter sign. All right, round it. Oh, can you see it? Round, sort of kind of right now. Oh, here it is. Here it is. Okay, so round it to the nearest tenth. What do we have? Period poo. I know, right? Matt saying 5.7. Do we agree with Matt? Okay, Michael's agreeing with the 5.7. Yes, Janice agreeing with the 5.7. Yes, sir. Yes, JB. Yes. Yes. So that means, I'm just going to switch it around. My x is approximately 5.7 units. So that will be my final answer. All right. So do not fear the trig. When you see something new and you're like, I don't know how to do this. This is terrible. I suck at math. You don't suck at math. You just wasn't presented with the opportunity to feel comfortable with math, to ask questions, because when you were younger, no one wanted to be that person that had questions because it took away from recess, right? Okay. So that's what I have. It's a little fuzzy. I need for you to get together, Robert. Because I'm going to give you my precious little baby. She's taking honors calculus. So you better straighten up. Give me my precious little Shyler. I love my girl. But it's time. It is time. Okay? You run all the time. No more running. Put the brakes on. But see, think about it. You run it and there's so many things. Like, how empowered do you feel now that you're like, oh, I know how to do this. Oh, that wasn't too bad. Like, how many times have when someone actually sat down with you and broke some stuff down, and you're like, you know what? That really wasn't that bad. Exactly. Okay. All right. Okay. So, gotta go. It's been real. Yeah, I'm not coming on later on. But I will be here tomorrow. And right now, I'm going to go into my fall schedules. So I'll be here. I'll be here at 9:30. Okay, Monday evening. Not quite sure what exactly. We'll see what the tutoring side of everyone brings, and if there is some things that people that are taking college algebra, especially, or even the ASVAB, or even T's. If there's something that you're like, hey, Audrey, can I go over probability? I saw that a couple times. I might do probability. Might happen. Alrighty? Real good. Push it. All right, guys. Have a lovely night. I will see you guys tomorrow. Please take care of yourselves and keep being awesome. Okay? Don't let anyone try to dim your shine whatsoever. I don't care how many people you think have done it. I want you to do it. If you feel powerful enough to get it done, do it. Okay? You want to start that business? Start it. You want to get those grades up to go. All right, let's get started. Let's just do. No more guessing. Oh, it has to be perfect. There's no such thing as perfect. Trust me. Okay? Trust me, I'm a perfectionist. Hi, I'm a former perfectionist, and I'm learning from my ways. All right? Okay, guys. I will see you guys tomorrow. Take care. Bye.